In this section, I'm going to talk about how I made this tileable mesh. It tiles left and right, up and down, and I was able to use the height map that I got from my systems graph and use it inside of ZBrush to deform a flat plane into this mesh with depth. It's quite a process. You might have to watch this video a couple times or maybe more just to understand the workflow. Looking at the final result inside of Unreal instead of Substance Designer of any painting program, just because this is the final place where we will assess if the colors of the texture are the ones that I want for my final picture. All right, so let's get right into it. So in ZBrush, I already made this piece. I'm gonna show you more or less what kind of references I was looking at when I was making this. Of course, I'm changing the shapes of the roof just to match a little bit the pointy look of the roof from my other reference, and I just want to see what actual slate roof looked like. It's very cheapy, it's very layery. So I went ahead and did the first pass on one of them. As you can see, it's got some thickness. So when I extrude it out, it looks very bumpy. It's not as flat, which is exactly what I want. I want some thickness on the roof. So I went and started just adding details here and there. Add some more of those layers. Really, I don't care much about the topology here because all I want is that alpha. I could make the pieces inside of Substance Designer, but I feel like this way is more artistic. I have a little bit more control. I don't have to move sliders. Okay, so once finished the first piece, I'm going to delete the subdivisions and going to add one of Boolean, one of the rocks that I previously made, and use it to create new shapes. Gotta make sure that it's one polygroup each. And it's just a matter of moving this piece around to create new ones. Good thing is that you can just duplicate the same one twice and get a brand new one. So this is the process that I will be doing just to create several pieces, maybe 6 or 7, to bring into Substance Designer. And when I'm done, just go to make Boolean. And I got a brand new piece that I'm just going to work on it. And I'll be doing this a few more times just to get different shapes. Save me some time. And when I'm done, I'll be going back to the Boolean pieces, try to fix them. I basically try to get rid of any 90-degree angle. Try to give it more of a 45-degree angle so our normal map looks better and there's basically no stretching. So the rule will be avoid 90-degree angles. Stay with the 45s or 30 angle. And I guess this is the time when you just plug in your headset and start listening some music and relax. Or in my case, I guess watch my stocks go down, which is not fun at all. So I'm just gonna go skip ahead and I'll show you the final pieces. Okay, so I made few broken and not broken, and then export the graph doc So make sure that you do this on a square document. 2048 by 2048 works fine. And then export each alpha and bring it into Substance Designer. So do not move the pieces around, just keep it center. All right, in Substance Designer, we see our alphas are connected. Since this is not going to be a Substance Designer course, for that you can go and watch other videos. I'm just going to show you lightly what I did over just to get my graph. I'm also not going to keep it too complicated. I'm going to keep it simple so I can show you how to do this. If you decide to do it more difficult or add more details, it's up to you. So I start with a tile generator and I change the input to images and I fit it right in there. The problem is that when you do this, you get you scale them up, they don't look overlap. Change the blending settings. So what we want is one on top of each other, like the roofs that we know. And also offset this. Well, that's why I need the next step, which is using the gradient map. And now we see that it's working totally fine because we just added that gradient over our picture. So that's the result we want. Next thing, we're gonna go to the viewer and click on the material viewer. We're gonna adjust the height map and add tessellation to the cube, and then select the material itself and then add a little bit of bump. So there you go. We added a little bit of that height or scale so it looks extruded. Okay, it seems to be fine. No noisy extrusions. Fast forward in time and I added some textures already. And I will show you the breakdown in a little bit. So one important note to view your cube, use ACES instead of sRGB. I think Unreal uses ACES. So whatever you see here is probably what you're going to see inside of Unreal. Okay, let's break this down. So we started with our alphas going into our tile generator. And then from there, it's split up in different sections. I ended up using a flood fill. That flood fill gave us color variations, kind of like a color ID. Then I use that to add different colors, blend it in with a bluish tone that I had already made. So I get different colors. Then I got an ambient occlusion node, invert it, fed it into the graph so I can get that brown color for dirt. And out of my normal map, I got the curvature. And then that curvature turned into a mask. and I'm gonna use it to add that detail, edge detail on my graph. Then I use that same ambient occlusion and I add that green color or the moss. And I just keep adding noises here and there. I mix noises to make new colors, and they just feed it to add variation. Added another mask. To get that brownish color. It's a really nice contrast between the blue and the hot red. And lastly, I made this a while back ago, a tileable moss. It already has textures, but if you don't have that, you can just use the moss that comes in some sense. I use mine out of a picture, so it's a bit different. Anyways, I just fit this into the final result, dilate a bit more, and then mask it out so I don't see a tile or tile everywhere, just in certain spots. And finally, just working that height map a bit more so it doesn't look very sharp. So it's got a little bit build up in between. And lastly, just roughness, nothing too complicated either. Okay, so now that we have our tileable and our height map, what can we do with it? Well, next thing we're gonna jump into Maya and ZBrush and gonna extrude this thing. Okay, so in Maya, I'm going to make this just basically a square. And as you can see, I have selected the inside, added a different color than the outside. Okay, so let's start by creating a 4x4. And then what we want to do is make sure that UVs line up, everything is perfect. Usually it works fine from the get-go. And then we're gonna duplicate and tile up, and then down, and then side. It's important that you do it this way. Then we're gonna cover every single corner, every single spot. So we inverse that and combine it. Now we're gonna have to get rid of some of that, so just trim it up, down. This is gonna serve as cushion in ZBrush. In fact, I'm just gonna get rid of a little bit more. We're gonna add one material to the outside and another material for the inside. Add a different color just to make sure we have two colors. And then we're gonna merge them, combine them, merge them. And in the end, we're gonna have one object that we're going to import into ZBrush. And there is our two materials that we can just select the inside and hide the exterior. Perfect. Now we're going to go and add subdivisions, remove smooth, and divide 1, 2, 3, maybe all the way up to 4 million, 1 million, depending how much detail. And we're gonna bring our displacement map or height map, import it here. Usually Photoshop works better, Photoshop files. Okay, now we're going to add 0.1 displacement. apply displacement, and our our object is now displaced. It's got all the detail, the height information in there, and I guess we don't need the lower subdivision anymore. Looks good, and we can hide the excess and delete it now. So that cushion helps us so it doesn't displace and it doesn't shrink. So now we go ahead and do a decimation, keep UVs, decimate again because it's too high, and good. It's a little bit too high, so the higher the worse it gets the stretching. So let's don't do much of that and export this into Maya. It came up a little short, small, so we just make it bigger by 100. And so the next thing is, okay, there's an issue here, which is our mesh came the opposite way. It's either the up is down and down's up. So either we go back to ZBrush and fix this, or we can just do it here in Maya. So I'm just gonna flip this minus 100 and then do a UV projection. And now it's up and down. Perfect. That's the way it should be. Next thing, we need to make sure that all the edges are basically at the border. So we need this to tile left and right without any interruption. We did that for all 4 corners. And then we also gonna have to make sure the mesh also falls in one of those edges. So it tiles perfectly on 4 sides. We gotta make sure we do this on the wall. Okay, perfect. Now, soften edge. We got our tileable, except that it doesn't tile. It's that huge seam that we need to get rid of. So we go to duplicate special, and we're gonna make sure it tiles 4 meters. Actually, plus 4 meters because we want it on the right side. And make sure that it's duplicate as an instance. So you can check that by grabbing it on each corner, and it should behave like that. Perfect. So this is the most, let's say, annoying part because I have to match every single one of those vertices to each other. So I have to go each and move it. So I move that vertex there. Try to match one side onto the opposite side. Don't try to match both. Just do one. One for the right side, one for the upside. And sometimes I just add, so when it's way too far, so I don't drag the whole piece, the whole vertex, I just go and add one extra edge loop or remove edges. For example, I'm deleting right here and add that vertex right in front of the other edge. So you'll be doing this for all of the sides, trying to get rid of that edge on all four sides. And lastly, we're just gonna make sure that our normals point up. So let's check the normals. So you go to display, polygons, vertex normals, and then vertex normal size. So we can see our normals are pointing different directions on our edges. I want to just keep them pointing at one direction instead of all four, just so this doesn't look like an edge seam caused by the normals. So at least all the normals on the edges will be pointing up and matching the direction. So you will have to do this little by little. On the C axis, nope, I think it's up axis. There you go. So it has to look like that, like the yellow ones. And then when it tiles, you're just gonna see, well, you won't see much of a seam because it's just pointing up. Unlike the other ones, they have information that it's average to its normal. And I'm just gonna show you how it looks at the end. I'm gonna add that color texture that I made. And make sure it tiles. It does. There's no holes, no gaps or anything. And this is ready to use.